Now,
Recording in progress.
again, remember, what I'm trying to show you is that it really isn't that difficult. All right, but it just requires some understanding, all right, of what's necessary. First of all, conjunction and disjunction, you guys know that from your English, right? Conjunction is and disjunction is or. I think that's correct for you guys in English, all right? But if not, that's what it is, all right? So a conjunction is an and statement, a disjunction is an or. I'm not going to ask you that, all right? What's important is that you're able to read these. Now, believe it or not, mathematicians don't like to write out sentences. All right. So instead of writing out a sentence, they'll just use what? Variables that represent sentences. All right. So P is what? A week has 7 days. Is that true or false?
True.
So that is true, right? If you want to put a true up here, that's okay. There are 20 hours in a day. That's obviously false. And there are 60 minutes in an hour.
True.
That's true. All right. Now, what you're going to do now is you're going to write the sentences out for 1, 2, 3, 4, 5, 6. All right. Now I'm agreeing it's kind of annoying. All right. So for question number 1, you would write that as what? And what? Yes, that is true. A week has 7 days and there are 60 minutes in an hour. And people every year say, do I have to write it all out? All right, well, I want you to get a good grade. All right, so the reason why you write things is the repetition. All right, that's what you're doing. What? Here is P. Hold on a second. Here is P and here is R. So you write a week has 7 days and there are 60 minutes in an hour. You agree with that now? That's all. And then it says, find its truth value. So is that true? Yes, because in an and statement, both statements have to be what? Both statements have to be true. Now, to me, I just think that's logical. I don't have to teach you that, right? And as we go through, you're going to be able to tell me, is the statement that you made true or false? That's what we're doing. All right. So just to recap, number 1, a week has 7 days and there are 60 minutes in an hour. That is what? That's true. All right. Now, this symbolism. All right. The way I remembered it was, it looks like an A. So that's a what? And this symbol right here is not an A. So it's going to be a what? Or. That's how I remembered it. All right. You remember it however you want. All right. But those are the symbolisms. All right. So now we're going to write number 2. Say number 2.
A week has 7 days and there are 20 hours in a day.
That is correct. All right. That's what you're writing down. Now, would you say that's, bless you, would you say that's true or false? That's definitely false. All right, now for number 3, I'll give you time. All right, I'll give you time. I don't want to rush it. It's important. All right, someone else, tell me about number 3. What's it going to say?
20 hours in a day or 60 minutes in a day.
There are 20 hours in a day, or there are 60 minutes in an hour. That is correct. Now the question is that true?
Yes. No,
James, why is it true?
because it can be either.
It can be either. Either one of them is true. Either one of them is true. That's what you need to understand about an or statement. Either this is true or this is true. Now I want you to hear me. Can they both be true?
No. Yeah.
Yes, they can both be true. If they're both true, then it's also what? True. All right. If they're both false, then what? They're false. In an and statement, both statements must be what? Or it's what? False. So if it's false, true, or true, false, or false, false, it's going to be what? False. Is that making sense? Or I don't think there's that much to it. All right. And statement, both statements must be true. Or statement, at least one of them has to be true. How about that? All right. At least one of them has to be true. All right. So which one are we on? So what do you think that squiggly line means?
And here.
What?
About.
It's just a symbol for not. All right. It's a symbol for not. All right. So it's the opposite of P. So what is the opposite of week of P?
Week doesn't have 7 days.
That is correct. That is 100% correct. Thank you. So now go ahead, Aiden, write this statement.
A week doesn't have 7 days, or there are 20 hours in a day.
That is correct. So tell me the truth value of that. It is definitely what? False, right? Because both of those statements are false now, correct? Now remember, as we go down, it's supposed to get a little bit harder. All right, so this is the time where you get on and say, hey, I don't understand what you're saying. Everybody good? Everybody good? All right. So now, someone else for 5. Go.
A week has 7 days, or there are 60 minutes in an hour.
Correct. Very good. And then what would you say for that?
True.
True. All right, now someone be brave for number 6. All right, Will, you gonna give it a shot?
A week doesn't have 7 days, and there aren't 60 minutes in an hour.
All right, I like that. A week does not have 7 days, or there are not 60 minutes in an hour. And so then obviously, Will, that's what?
False.
False. Yes, sir.
Wouldn't it be and?
Didn't I say and?
You said or.
Did I say or? I meant to say and. Thank you. And. All right, that symbol is and. Thank you. Now, does everybody agree? I just don't think that's that hard. All right, the symbolisms, I don't think is that hard. All right, now what I want everybody to do is, when something is written if in the if-then form, it's called a conditional statement. All right, it's called a conditional. All right, write each statement in an if-then form. What?
If someone's 16 years old, they're eligible to drive.
That's all there is to it. All right, say it again.
If someone's 16 years old, they're eligible.
Right. Now, again, I don't care if you say if a person is 16 years old. All right, I'm not the English person. All right, but I like for it to sound like it's correct. All right. So now we're just writing these as conditional statements. All right, come on, someone else now. Tell me about 8. Ben, go ahead.
Cheese contains calcium.
So if you had to write that in the if-then statement.
Then
If what? Shh.
if
You can say it. If it, someone help him. Someone else. Come on. Harrison, what do you think? for number 8. If, I know, I don't like using pronouns either. It's kind of hard, isn't it? But you can just say what?
It is cheese.
Right, if it is cheese.
It contains calcium. Or
Then it contains calcium. If it is cheese, then it contains calcium. Now I want someone to think about number 9, how you have to write this one. All right, Michaela.
If it is an acute angle, then the measure between 0 and 90.
Now, what I want to do is, that's perfect, but I always try to tell kids to try to avoid pronouns, right? So I don't want to say if it. What is it that we're referring to? Yes, right. So instead of saying it, up here, I was thinking long about how do I not make number 2 it, right? Whatever's in front of you, right? I don't know how else to describe it, right? If what's in front of you is cheese, then it contains calcium. If you want to write that, that's fine. All right. But I didn't know how else to say that. So we generally don't like to use pronouns. So in this case, we would just say if and what? If an angle is acute, then what? Yes, then it's between 0 and 90. It's okay to use it the second time. All right, because we know what we're referring to. Anybody have any questions with that? All right, Abigail, you could help me with 10. What are we referring to?
Triangles,
Yes. R. Yeah.
parallel,
Mm-hmm.
and they're
Angular. Yes, there you go. Simple as that. Again, we're referring to the triangles. If triangles are equilateral, then they are equiangular. If triangles are equilateral, then they are equiangular. Okay. Now, the next part of the lesson, 11 through 18, I think is difficult for most because you have to think of all possibilities. You have to think of all possibilities. And a counterexample is just the example that proves your conjecture false. All right. And what's the conjecture? The conjecture is just a statement here. All right. If x squared equals 16, then x equals 4. Can someone tell me if that's true or false? So far, I have 2 truths. Anybody else? Tell them, Lexi.
True.
False,
Why?
because it could also be negative. 4.
That is true. That's just how annoying it is, guys. That's just how annoying it is. All right, it's so easy to just put true down, right? It's so easy because it looks like that's the only possibility, but that is not necessarily true. Does everybody agree with that? So that's what's hard about geometry is you have to see all possibilities, and that's difficult for kids to do. All right. So in this case, we're going to say false, comma, x could equal what? X could equal -4. Now, number 12, I just never was a big fan of these, but I think we can all say 12 is what?
False.
False.
Right, because why?
There's more than one Atlanta.
There's more than one Atlanta, right?
Atlantis.
All right. Does everybody see that? There's more than one Atlanta. All right. So again, I'm thinking it's what? Definitely false. All right. I don't know where the other Atlanta is, but
Augusta, right? Isn't there like one?
no, the name of it is Atlanta. There has to be another Atlanta that's not in the state of Georgia.
Oh, yeah.
You see what I'm saying? Atlanta, anywhere in the world. All right. I'm sure there's another Atlanta somewhere. All right. So that's false. And if we want to look up where another Atlanta is, that might be okay, but not necessary. We just know it's false. All right, let's look at 13. If tomorrow is Friday, then today is Thursday. Is there any other possibility? I don't think so. I think that one's definitely true. Obviously, 14 is what? False. You could just name any other animal, right, with a spot on it.
You have to give a reason for all of them.
No, like I said, this, just the false one is when you're supposed to give a counterexample. But to be honest, I don't know another city that's named Atlanta that's not in Georgia, but I know there is.
Yeah.
Right, so if you want to look that up for me, that'd be good. All right. What?
There's 24 places called
There's 24 places, thank
Atlanta.
you. 24 places in the world called Atlanta. Thank you very much for that information. All right. So 15. If the measure of a right angle is 95, all right,
Actually, these are lizards. From the sound. No? Yeah.
my spider senses.
We should just put like false.
Wait, how do you get the
makes no
answer?
sense.
Watch me true.
Here we go, guys. This is why I put it up here. And this is what I want to tell you something. Now, listen, I put the solutions, posted them because, again, I try to tell kids all the time. Some of this is just people got together, and for some that are smarter than me, made this logic. All right. So they made it logical, right? I'm not claiming to understand the logic. All right. I always said number 15 was what? I always said number 15 was false, but the answer in the book says it's what? All right. So listen, I understand. We're not going to argue about it. It doesn't make sense to me either. I've looked it up every single year. All right. And it made no sense. All right. It's someone else that made up the rules. Trust me, the rules are important for logic. I wish we were spending more time. Just listen to me. I wish we were spending more time on logic. All right. But we are not. All right. So I'm going to try to explain exactly what their thinking is. All right. So it says, if the measure of a right angle is 95, then bees are lizards. All right. So here we go. It says right here, the conditional statement, if the measure of a right angle is 95, then bees are lizards is true. I don't know why it's true, but here comes the explanation. It says, because the hypothesis is false, and I should have mentioned this, this is the hypothesis. And this over here is the what? Conclusion. All right. Because the hypothesis is false, since the measure of a right angle is 90, a conditional with a false hypothesis is always true. I looked it up for so many years. I've tried to get a good explanation for why it's true. And guess what? I haven't found it. All right. But for whatever reason, they decided to say, if the hypothesis is false, then what? The statement is always what? The statement is always true. And every year I try to tell kids, I didn't make this up. It's not my opinion. All right. It's what they're telling me is true. And that's what's difficult about geometry. There are things that you have to accept that are what? True. All right. That's it. I don't like that explanation. I've tried to look up the explanation of why that's true and have not found anything that I'm going, oh, well, that makes sense. All right. Everywhere I go, they say, That's the reason, because it's true. All right, without a good explanation. If you want to try to look it up and bring it to me with a good explanation, I'll be happy to give you some extra credit. How's that? All right. If you want to look that reason up for me and bring it to me, all right, and I look at it and go, okay, that makes sense, then I'll give you some extra credit for it. All right. So again, I'm just pointing this out. It's going to be on your test. I'm going to write something absurd and you're going to laugh and you're going to put false. And then I'm going to get the last laugh because it's what? It's true. All right. So if you're not careful, you'll be the one arguing with me over this. And I'm going to say, I can't argue with you. All right. I don't know why. I'm just telling you that's what they told me is true. All right. And eventually, if you go to college and you study math, they will show you all of the explanations to the logic. All right. It's very strange. All right. And again, for me, when I went to college and I learned this stuff, it was just memorize it because it doesn't make sense. All right. That's what I thought. All right. So keep that in mind. All right. Again, you might want to write this down. If the hypothesis is false, the conditional statement is true. All right. So here we go. Let's go back.
15 false.
Hold on a second. I'm not there yet. Okay, here we go. 16. Yeah, this is another one.
Well, should we fix the explanation?
If pigs can fly, so this one we said now is true. All right, there is no explanation, right? It's there. It's if it's false, you write the counterexample, right? So if pigs can fly, obviously pigs cannot fly. So regardless of what comes after it, it's what? It's true. All right. I like I said, we're just going to write true down. All right. Now, if Jacqueline turned 14 years old last year, then she will turn 15 this year. I think that's true. If a number is between 10 and 11, then between 10 and 12, then it is 11. Obviously, false, because we could put anything besides what? 11. I'm happy with that. All right, so hopefully I taught you just a little bit today. All right. Not much. All right. And that's why I'm telling you, does everybody hear me? Right? There's just some things just you have to put in your memory. All right. And that's goes in. I hate learning math that way. It is because I say it is. All right. I usually like to try to show you why. All right. So in that case, I can't. Now flip the page. All right. Now we want to learn about the converse, the inverse, and the contrapositive. All right. So the converse. All right. Now, first, I want to write a conditional statement for you. So please look up. That's the symbolism for a conditional statement. So what does that actually say? Not P, but if P, then Q. All right, this is the conditional. Is everybody with me on that? That's the conditional. All right, so converse. All right, converse would be if Q, then P. All right, that would be considered the converse. All right, and we'll talk about the fact that the converse doesn't always have to be true, but it could be true. Okay. No. Listen to what I'm saying. Converse is when you switch the hypothesis and the conclusion. You with me on that? All right. Because the reason why I don't like what you said is because next one we're getting ready to do is called the what? Inverse. And the inverse is the negation. So you would say, if not P, then not Q. If not P, then not Q. And that is called the what? That is called the inverse. All right. And next, the contrapositive. the contrapositive is a combination of the converse and the inverse. All right. So the contrapositive would be if not Q, then not P. That would be the contrapositive. Now, I want someone to make a note to yourself because it's going to come up on the test. If the conditional is true, the converse can be true or false. The inverse can be what? True or false. But the contrapositive is always true. All right? If the conditional is true, the contrapositive is always true. If the conditional is true, the converse can be true or false, and the inverse can be true or false. Is everybody with me on that? All right. And we're going to go through some examples here.
If what's true.
If the conditional is true, if the conditional is true, the converse can be true or false. The inverse can be true or false, but the contrapositive is always true. All right. If the conditional. All right. Part of the reason why I'm going through this is because I've seen it on the SAT now. All right. There's been a question or two dealing with converse, inverses, and contrapositives. All right. So now that you understand the notation, all right, you should be able to apply that to our questions. All right. So what I'm going to do now is I'm going to bring number 19 down below, and then we will write it out. All right. So here we go. Right. If a number is divisible by 4, then it's divisible by 2. So what is the converse?
True.
No, I'm not asking about true or false. I'm asking you to state the converse. Tell me, Maren.
If one number is divisible by 2, it's divisible by 4.
That's how simple, guys. That's all there is to it. That's all there is to it. Anytime you want to write the converse, you just switch them. If a number is divisible by 2, then it is divisible by 4.
False.
All right. And that one's definitely false. So does everybody agree? Originally, someone was screaming true or false. I was kind of ignoring you because I wasn't interested in that question right now. But can anybody tell me the conditional statement, is that true or false now? The conditional statement is what?
True.
True. The converse was what? False. That's what I'm trying to tell you. All right.
Can I just write T, F?
Listen to me. You're going to take a test and I'm going to say, write something out. You with me? I'm not a pain. All right. I'm learned by, I have a good memory as far as that goes. All right. But I don't want you, when you take a test, to make a mistake because you haven't done the exercises. That's all I'm trying to tell you. All right. I'm not a babysitter, right? I'm telling you to do something for a reason because I want you to do better on your test. On your test, you're going to have to write things out. You understand me? All right. That's all. All right. So we said the converse. Now I want the inverse. Come on, someone else say something today. Olivia, say something for me. What do you think the inverse is?
Not,
Yes, it has not. That's correct. If,
well, I'm trying to read it.
yes,
If it's not divisible by 4, then it's not divisible by 4.
that is correct. Very good. It's really, really simple, but you have to practice. If a number is not divisible by 4, then it's not divisible by 2. Is that true or false? Definitely false, right? Because 6 is not divisible by 4, but it's divisible by 2. All right, is everybody happy with that? Now, because we said the conditional is true, then automatically what's true about the contrapositive?
True.
It is true. All right. So Catherine, do you want to do this one? The contrapositive. Remember, it's just switching them and negating them. It's a combination. It's okay. You don't have to.
Oh no, I'm kind of confused about that one.
All right. So are you confused about the second one?
I'm confused about the contra.
Positive.
Like, I
Okay.
get that it's true, but like, how do you say that?
All right. So I'm going to let someone say it to you. All right. And again, please, guys, some of you, I'm really trying to help. But if you're sitting there just writing things down blindly, it's not helping. All right. So you have to understand the concept. All right. So listen to Kate Mitchell. Go.
If it's not divisible by 2, it's not divisible by 4.
Right. So the contrapositive is switching the statements and and saying the opposite.
So it's kind of just like both.
It's both combined. That's what the contrapositive is. All right. So say it again, Kate Mitchell.
If it's not divisible by 2, it's not divisible by 4.
Exactly. All right. And that's obviously what? True. It's obviously true. All right. Now, please, I'm asking for help. Yes.
Like, I have a question about like number 14 and 12. Like, if those are conditional, why aren't they true?
I don't know. Say it again.
If it's conditional, isn't it already true?
If an animal is spotted, every spotted animal is a Dalmatian, is what you're asking me.
No, it's not, but like, I'm confused because the number 6 and the 6 and 5 is 2 plus 5 equals 7.
Well, this is false. That's false.
Yeah,
If an animal is spotted, is that false? Right? Do you understand me now? Right? I understand your question, right? Pigs definitely cannot fly. That animal is spotted. All right? They're telling you that's true. I hope that's a good explanation for you. All right, so back to 19. Does anybody have any issues with 19? Yes.
Why are the inverse and the contrapositive not true? Or why are the inverse not true?
So your job is to tell me of a number that's not divisible by true or by 4 can't be divisible by 2. And I said the number 6. 6 is not divisible by 4, but it is divisible by 2.
Okay.
Right?
Yeah.
Yes, Lexi.
When it's false, we still have to write an example.
No, I didn't. I didn't even read the directions. If a statement is false, yeah, it does say that. Thank you, Lexi. Find a counterexample. All right. So I gave you a counterexample, I believe in both of them, didn't I? We said that if a number is divisible by 2, then it's divisible by 4. Right, so we could say 6 again, right? Does that make sense?
Yeah.
All right.
Would the contrapositive be true?
The contrapositive is always true if the conditional is true. And we established that the conditional was what? We established the conditional is true. All right, so the contrapositive is always true. All right, those are little details that, they're going to ask you on the test. All right. So number 20, all whole numbers are integers.
ooh,
So we could say, look, I don't think it's written properly. If a number is a whole number, then it is an integer.
true.
If a number, I'm going to rewrite that for you guys because I don't think it's written properly. If a number is a whole number, then it is an integer. Okay, so now, Nate, tell me what the converse is.
The converse is
And by the way, we said this was true. So what's the converse? Yep.
If all whole numbers.
No. If a, what are we referring to? If a what?
A whole number?
No,
Oh, no, an integer,
no,
a number?
you're just referring to a number.
Okay.
All right, it, and again, I'm not very good at grammar. All right, but I know that it refers to what? Number, right? So we can say, instead of it is, if it is, we can just say if a what? If a number is a integer, then that is correct. Do you understand me now? All we're doing is switching. If a number is an integer, then it is a whole number. Is that true or false?
False.
Definitely false, right? Because you can be a negative and a negative is not a whole number, correct? All right. Chloe, I haven't heard from you today. So tell me about the inverse.
Last one.
Shh.
If a number isn't a whole number, then it's an integer.
That's exactly correct. If a number is not a whole number, then it is not an integer. Is that true or false? False, definitely false. You could just say -3 or -2. Everybody okay with that?
Where are you putting the answers?
I don't know what you mean. I'm not writing the answers. You are.
Oh,
All right. Now, we just did the inverse, right? So Elise, you want to give it a shot for the contrapositive or not? Thank you. Give it a shot.
If the number is not an integer, then it is not.
Yeah, you're awesome. All right. If a number is not an integer, then it is not a whole number. Yes,
Does the conditional always have to be true?
no.
So it can be false.
Mhm. You see what I'm saying?
Yeah.
Right. Tell me.
What we would write for converse, I know it's false, but like what would we write for like the counter example?
Whatever, so for the converse, so it says, if a number is an integer, then it is a whole number. -3 is an integer, but it's not a whole number.
Okay,
Do you agree with this?
yes. So I kind of write -3.
Yeah, for a -3, or if you want to be original, you can do -2. But now you have to pick another number, right? Because I just told you -3 and -2. I don't care, you know that. Okay, so listen. Now, boy, we're almost out of time. All right, I still got to talk to you about biconditional. All right. So biconditional, all right. Biconditional is if and only if. All right, if and only if. So if the conditional is true and the converse is true, you can write it as an if and only if. And I'll explain that. And if and only if can be abbreviated as IFF. All right. And I'll show you that. All right. And I only have like 2 minutes. All right. So I apologize for that. Here we go. 21. Two angles whose measure add to 90 are complementary. Is that true? Two angles whose measures add up to 90 are complementary. Is that true? So if two angles are complementary, then they add up to 90. Is that true? So now you can write an if and only if. All right, so what is that? You would say two angles whose measure add to 90 if and only if they are complementary. Two angles whose measures add to 90 if and only if they are complementary. And that, I guess, is just an abbreviation for telling you that the conditional is true and the converse is true. Wait a minute. Instead of saying whose measure, that doesn't make sense. Two angle measures add to 90 if and only if they are complementary. That makes better sense. See, my English is not very good. Two angles that add up to 90, two angles measure, well, we'll finish it tomorrow. Well, we won't finish it tomorrow. You guys try these problems now. Try 1 through 57. All right, now I also posted the solutions. Do you agree with me? Did everybody see that? Did everybody see I posted the solutions? Because I think it's annoying to write something and not know if it's true. All right, I'm happy with today, guys. Good job.